Okay, so this is my functions tutorial on using radicals in the quadratic formula. So there's just some basic things that we need to get out of the way first. So what is a radical? A radical is essentially anything that is under what this is, it's a root. So for example, you could have any number under here like root 33, and this is considered a number in its radical form. This number in its decimal form would be 5.744, blah, 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 blah. So the reason that we leave stuff in radical form is to keep it in the most exact or most correct form, which is like no decimals. Yep. So what we're solving for is x-intercepts on a parabola. So those are these thingies on a parabola. So on a graph, it would be these points on the x-axis. So that's essentially what we're solving for. Then you need to know what a perfect square is. A perfect square is a number that when it's square rooted or squared, it equals another whole number. Common ones are just 1, 4, 9, 16, 25. Anything like 4 squared is going to be 16. 16 squared, square rooted is 4. So let's get into an example. So here we're told to find the exact solution of this equation. So when we see exact, that kind of tips us off. That's like, okay, we're finding something in radical form. We have to leave it in the most exact form, no decimals. So I have some steps written out here, and we're just going to follow them. Step 1 is identify and write out the A, B, and C values. So this is A, B, and C. So we're going to just write those out. So A is 3, B is -10, C is 5. Okay? Step 2 is to plug the A, B, and C values into the quadratic formula. So x equals -10 plus and minus square root of b squared. So -10 squared minus 4 times 3 times 5. All of that over 2a, which is 2 times 3. So now we plug that in. Step 2 is done. Step 3 is simplify or solve. So we're just going to multiply anything that needs to be multiplied, all that jazz. So here we have a double negative, which equals a positive. So it would just be 10 plus and minus. I already calculated this, but you would just essentially plug this into your calculator exactly how you see it. I got root 40 over 2 times 3, which is 6. Okay, step 3 done. Step 4, simplify radicals using perfect square. So this is where it kind of gets difficult. Inside this radical, we have to find a multiple that is one a perfect square and the other one something that cannot be squared. Square rooted into a whole number, I mean. So inside this, when I see 40, I immediately think of like 4 times 10, okay? So I know that 4 is a perfect square, and I know that 10 cannot be square rooted into a whole number. So that is when I know that 4 and 10 are the two perfect multiples for this. So I'm gonna rewrite these out as x equals 10 plus and minus 4 times 10 over 6. And this will equal 10 plus and minus. I'm going to square root this, and I'm going to get 2 root 10 over 6. So that's step 4. Step 5 is then common factor the numerator. I cannot stress this enough. You will not common factor the radical. This is a very common area of mistakes that people do. So just make sure you common factor the numerator, everything except the what's under the root. So I see 10 and 2, and I immediately think, okay, 2 is a common multiple of these, so I'm going to take out a 2. So then this is then going to be x equals 2. 10 divided by 2 is 5, plus and minus cancels out. I could write 1, but there's technically a 1 attached to this root anyway, so I'm just going to write root 10 over 6, because we only common factor the numerator, not the denominator, and not the radical. So step 5 is complete. Step 6, cancel and simplify. So I'm going to go back to this step over here when we had a 10 and we had a 6. Okay, we cannot cancel these out because there's addition happening, which is just a big no-no. You can't cancel out because there's addition. But now that we've common factored, we're now left with multiplication, so we can go ahead and cancel these. So 2 divided by 2, because 2 and 6, 2 divided by 2 is 1, and 6 divided by 2 is 3. So step 6, cancel, is done. Then we're on to step 7. We're going to write x equals 1. We're just going to kind of rewrite it. 5 plus and minus root 10 over 3. And now I have to split these into 2 x-intercepts because that is essentially what we're solving for, right? So this is where the plus and minus comes into play. It's going to equal 2 separate things. So x1 is going to equal 1. 5 5 plus root 10 over 3. And the second x-intercept is going to equal 1, 5 minus, because we split these up. So we split 1 here, minus root 10 over 3. So yes, these are your two final answers. We're gonna box these up. The paper cutout at step 7, so I'm just gonna tell you guys what I did. I basically just rewrote the equation here. I wrote 1, 5 plus minus root 10 over 3, because I had just already canceled those out. I'm just gonna split these into two x-intercepts, so I did x1 and x2 right here. So x1 is this, x2 is this. So these are like, you basically wrote the same thing, you just really had to change the plus and minus sign, and that is how you use radicals in the quadratic formula. Thanks.